Hello, welcome to the fourth lesson in the Learn to Love Sudoku series. If you haven't seen the first three, that's okay, as long as you're familiar with basic pencil marking notations that I use for center and corner, as well as the techniques of naked and hidden singles, tuples, both naked and hidden, as well as the X-wing technique. In this lesson, and if you aren't familiar with any of those, please feel free to go back and watch my previous lessons. Also in my previous lessons, I do have packs of puzzles for you to practice those techniques. And in this lesson, I have the same. So in the description below, you'll be able to find a list of puzzles. And I will be solving one of those after the initial lesson to sort of drill home how this works. So in this lesson, I'm going to be teaching the swordfish and the jellyfish technique, which I sort of group into the fishes. Both of these techniques are essentially extensions of the concept of the X-wing. So if you don't understand the X-wing yet, definitely recommend going back and reviewing that, maybe practicing some X-wing puzzles, because the swordfish and jellyfish are basically an expansion of that concept. So hopefully this lesson will be relatively quick because I am going to assume you understand the X-wing already. So the first thing I'm going to do is bring up an example. So this is the first example, and this puzzle contains a swordfish. So the basic concept here is very similar to the X-wing, except every time it's 2, it's 3 instead. So if you remember, the X-wing, we found either 2 rows or 2 columns where a specific number could only appear 2 times, and the place that it could appear was the same in both of those rows or columns. So here we have a swordfish on rows. So if we look at rows 3, this is row 3, row 5, and row 8, we have a swordfish on 9s. And what that means is if we look at where 9s can go in these rows, I'm just going to highlight that in blue here. So in these rows, the digit 9 can only appear in the blue cells. And so because we found that on rows, what that's going to do is it's going to eliminate those values on the columns. And so in these columns, we're now able to eliminate, wherever I've marked orange, so for the rest of the columns that aren't marked blue, that participate in where 9s go in these 3 rows, we'll be able to remove 9 as a candidate from those cells. And in this case, we now have a naked single 2 that we can fill. So let me go over why that is. And the idea is very similar to the X-wing. So if you think about it, how many 9s can appear in one row? Well, the answer is obviously 1. And so how many 9s can appear in 2 rows? Well, 2. And how many 9s must appear in 3 rows? Exactly 3. So in these 3 rows that I have highlighted here, we have to have exactly 3 9s. And if you think about how you're going to do that, well, the only way that's going to happen is if each row contributes 1 of the 9s, and they must contribute their 9 in a column that is different than any of the other rows that are contributing. So for example, in the final puzzle, I might have a 9 here, in which case the 9 now can no longer be here. And that basically leaves us, or here, right? And that basically leaves us with an X-wing on 9s for the rest of the 2 rows. And so then now for these rows, I could do maybe 9 here and 9 here. But I obviously can't, because the 9 is limited to the same 3 columns in these 3 rows, there's no way I'm going to be able to use a 9 in these rows in such a way that I haven't used up the 9s for those columns. So hopefully that's clear. And again, it's essentially the same as the X-wing logic. And so just to drill that home, if this cell here were a 9, because we did mark it as a 2 or a 9 possibility. But if this cell were a 9, it would eliminate 9 from these 3 here. And now I have to place 3 9s in these 6 cells, and there's just no way to do that without repeating a 9 in a column. So there's no way this cell here is a 9. So however you want to think about that, this cell is a 2, not a 9. And we've eliminated 9s from all of these orange cells. Okay, so I'm going to bring up my second example here. And so that is called a swordfish, just in case I didn't name that. Again, just like the X-Wing at least had some sense to it. I have no idea why it's called a swordfish. You might want to call it a 3-fish. I don't know. No one's going to call it a 3-fish. It's called a swordfish. So you just sort of have to memorize that name. And similarly, we have another fish in our aquarium, which I will pull up right now. Let me just close my other tab first. So here we have a jellyfish. And a jellyfish is the next step, as you might imagine, where an X-Wing is a value that's restricted to the same 2 columns in 2 rows, or the same 2 rows in 2 columns. And then the swordfish is 3 and 3. And so the jellyfish is 4 and 4. So here, I mean, I've made it obvious in my examples here, but I'm just going to highlight these cells here. And I will highlight those blue again. And now I will highlight the rest of the columns in orange. And so here, what you can see is, if we look at where 9 can go again, in row 1, row 3, row 5, and row 8, the 9 is restricted to column 2, column 4, column 7, and column 8. And so in 4 rows, the digit 9 is restricted to the same 4 columns. And it doesn't matter that this 8 is filled in. Like you can have ones missing in any of these rows. But if you sort of take the union of the rows, we have the same exact 4 columns to put a 9 in 4 different rows. And so it has the exact same effect here. And here I've marked this 5, 9 to show that it makes a naked single. So this cell that's orange can't be 9, so it must be a 5. And if you think about it, this is the exact same situation where I have 4 9s to place in 4 rows, and they have to go in the same 4 columns. So if I try to put a 9 anywhere else in the column, that's going to, that would make this a 6, a 2, and this a 3, 5 candidate. And so now I have to put 4 9s into these cells, and there's no way to do that without repeating a 9 in a column. So another way to think about that is one of these is going to be 9. Let's say it's this one. One of these 4 in this row is going to be 9. So that prevents any of these 2 from being 9. Or these 3, I should say, even though this one never could have been 9. And so then that leaves a swordfish. Right, and then this swordfish, one of these is going to have to be 9, and then that leaves an X-Wing. So, oops, I am highlighting the wrong cells. There we go. That leaves that X-Wing there. So it's the exact same concept. It's just now it's 4 and 4. So you may say, oh, well, what's the 5 and 5 called? Well, it doesn't have a name, and I will explain why. And it's actually very similar to single versus hidden. In terms of tuples. So if you remember my lesson on tuples, if you watched that one, a naked pair, let's say within a row where there are 9 possibilities still, if you find a pair in that row, a naked pair, that means you've also found a hidden septuplet. So if you find a naked triple, you found a hidden sextuplet. If you find a naked quadruple, you found a hidden quintuplet. And then they flip, and if you find a naked quintuplet, you've now found a hidden quadruple. And so instead of calling it a naked quintuplet, we'll call it a hidden quadruple. So really you only need ever 1 through 4 for tuples, and then you just call it you call it a naked or a hidden. And in fact, you could call a hidden single, instead, you could call that a naked octuplet, because they're the exact same concept. Within a row or a column or a box, we have limited a particular value to only be available in one cell. which means if you were to look at the other 8 cells, they make an octuplet because they don't contain that one digit. So in the same way, we have X-wing, and if you sort of think about it, a hidden single is essentially an X-wing, or the one fish, right? You have one value limited to one place, or one column in one row, right? Or if you rotate that 90 degrees, you have one value limited to one row in one column, which is also known as a hidden single. So the X-wing is basically an extension of the hidden single in a different dimension. Just like the hidden pair is an extension of the hidden single along a row or a column or within a box, the X-wing is an extension of the hidden single in the area of how many rows and columns is this digit available, and having those rows and columns match up. Similarly, we can then extend it to the swordfish and the jellyfish. But why can't we do a 5-fish? Well, we can find a 5-fish. And in fact, if you look at what I've had on screen for a while now, the green cells, if those were where, within these rows, if that's where a particular digit were limited to, we could call that a 5-fish. And then because we limited it on the rows, we'd be able to eliminate these cells from having, these highlighted ones, from having the value that we've limited to the green cells. But actually, I missed some here, these as well. So because we found it on the rows, it limits it in the columns. So you can see in the columns where I have these greens, we have oranges in the rest of the column, which signifies that whatever digit we've limited to just these green cells in those rows, now these columns that are orange are the only columns that or cannot have that value. And so remember, we found that 5-fish on the rows. But by essentially definition, if you look at the puzzle rotated 90 degrees and you look at columns instead, because we were able to find that 5-fish on rows, that means that there has to exist a jellyfish on the same number in the columns for the rows that we found the 5-fish on. And I'm sorry if that's difficult to explain. That's why I tried to make this visual here. So the blue cells have to be, if the green cells are a 5-fish on rows, then the blue cells must be a jellyfish on columns. And that's the same as a naked single versus hidden single. Once your naked singles start getting 5 or higher, you should start calling them hidden singles and do a 9- on that. Here, if you find a 5-fish, there's no name for it because that means you've also found a jellyfish. You just have to sort of rotate the board and that, look, instead of looking at rows, you look at columns. Instead of looking at columns, you look at rows, and you will find instead of the 5-fish, you will find a jellyfish on the same numbers. And if you look, by definition, it has to be true because within these columns, these cells, which I'll highlight, I don't have every cell highlighted, but I'll highlight these purple. So these purple cells can't be the value that we've limited to the green cells in these rows. Otherwise, we haven't limited that value in those rows to just the green cells, right? If this cell could be the value we're looking for, let's say 9s, right? Let's say I'm just going to mark 9s in these greens because I hate that I'm having to be so general. So I'm just going to center mark 9s in all of these, right? So we've said 9 can only be in the green cells in these rows. In the other rows, we don't know. But in these rows, 9 can only be in the green cells. And we said, oh, I found a 5-fish. I don't have a name for it, but it's a 5-fish. It's a natural extension of the jellyfish. But if you look, these purple cells then can't be 9. There's no way they can be 9. Otherwise, we haven't actually limited it. We haven't actually found a 5-fish if this cell can be 9. So none of these purple cells can be 9. So if you look at the columns that contain these purple cells, there are 4 of them, and the blue cells, the cells that aren't purple, which I've marked blue, are the only cells in these columns that can be 9. And so we found a jellyfish on columns. And what is the effect of the jellyfish on these columns? Well, the rest of the row, the orange cells are exactly the cells in the rows that we've limited 9s to that would eliminate 9. And so my green 5 fish eliminates 9s from the oranges, but also my blue jellyfish eliminates 9s from the oranges. So I found the exact same pattern. So you never have to have a name for a 5 fish or a 6 fish or a 7 fish or an 8 fish, because there is already a name for it. You just got to sort of tilt your head. So the 5 fish, if you find a 5 fish, you will also find a jellyfish. Just instead of on rows, you do it on columns, or vice versa. Instead of a 6 fish, you have found a swordfish. Instead of a 7 fish, you have found an X-wing. And instead of an 8 fish, you have found a hidden single. So that is why there is no name for those. So hopefully that's clear, and hopefully that kind of, going through this, I hope it wasn't too slow for you, but I really wanted to drill in that you never have to look for more than 4. Just make sure you're looking on both rows and columns. Now, of course, if you do spot the 5 fish, you can feel free to go ahead and use it, but you might want to sort of tilt your head and look to see if maybe there's a different fish on the columns that's more useful. So that is the lesson. So what I'm going to do is I'm going to solve a puzzle that is going to require a jellyfish, because I don't really see a reason to solve a swordfish puzzle. I don't want to make the lesson too long and end up solving both a swordfish and a jellyfish puzzle, because these puzzles are not trivial. So I have chosen one of the swordfish puzzles, and there's a pack of puzzles in the description. Philip Newman has again provided that pack, which I think I forgot to credit him at the start, so forgive me for that. Philip Newman has created the puzzle that I'm about to show you, and he also created all the puzzles in the description. 5 of them are swordfishes, 5 of them are jellyfishes, and I will separate them out so that you know what to look for. So let me open the puzzle that we're going to solve. And here it is, and it actually looks like a jellyfish. This is obviously a constructed puzzle, right? At least a human has gone and made it fun. So the cool thing about this puzzle is it looks like a jellyfish, and it contains at least one jellyfish. So if you'd like to try solving this yourself, it is going to be the first link in the description, which I will label as the one I do in the video or something, probably more eloquently than that. But go ahead and try it yourself first. See if you can spot one or more jellyfish in this puzzle and see if you can solve it. And I am going to solve it right now. So, and sorry, I should say this puzzle is called Totes Jelly, and it's by Philip Newman. So one thing that you're gonna, if you're thinking about whether a puzzle is gonna contain fishes in it, this is a really good clue that it will. And this is basically what I've highlighted here. Let me just give it a nice little highlight here. So, and I just noticed that, well, I noticed when I started this video that FPuzzles just pushed out an update. We have more colors, and I'm super happy about that. So thank you to Eric Fox for giving us more colors to work with. That's great. Anyway, so we now have this pale pink color, which is actually kind of nice. So the ones I put in pink, in these, we can see that they sort of create a, if you sort of imagine if we eliminated the rows and columns that aren't involved in this, they make kind of a 4x4 box. And it should be pretty easy to see that. And if you ever get a puzzle where you see some kind of like 3x3 or 4x4 or even 5x5 box, and if you look at the box and there's a missing digit from every cell in that box, so it doesn't contain all of 1 through 9, then there is probably going to be some kind of fish or X-wing on that digit. Now, if you actually look, we're missing more than one digit. We're missing 5s, 6s, and 9s from the pink cells. If you look, we have 1, 2, 3, 4 at the top. We don't have a 5 or a 6 when we have 7, 8, and we don't have a 9. So we could have a jellyfish or a swordfish or some kind of fish pattern on 5s, 6s, or 9s. And what we need to look for is a given 5, 6, or 9, or maybe, you know, solve the puzzle a little bit and we'll get it like a naked or hidden single that becomes one of those in a column or row that is not the present in my little 4x4 box here. And that's going to eliminate that digit from one of those columns or rows, and that's going to create a jellyfish naturally. So starting with 5s, we have this 5 given here. So if we look, the 5 is eliminated from these 4 cells. And so just by necessity, in terms of how this is laid out, that creates a jellyfish on 5s, and I'll mark that blue here. So in row 1, row 5, row 6, and row 7, a 5 can only be in column 1, column 4, column 8, and column 9. So we have the value limited to 4 columns in 4 rows. And so this is a jellyfish. This is a jellyfish on 5s, where I can mark in orange these cells here, just to be consistent with what I've done before, and none of the orange cells can be 5. But let's not stop there. So I'm actually gonna unhighlight that, and we also are missing 6s and 9s, and you can see we have the same thing. We have a 6 and a 9 that aren't in these rows and affect a column that aren't one of these columns. And so this 9 here is going to just naturally create this jellyfish on 9s. And this 6 here is going to naturally create this jellyfish on 6s. And so we can sort of shortcut a little bit and go, we have kind of 3 overlapping jellyfishes, all in the same rows that affect essentially the same columns. Because if you think about, let's say this 5 here, right? Sure, the jellyfish isn't really affecting this column, but that's just because we have the given already. So I'm going to mark in orange, all of these cells here. So the cells that kind of are the intersection of, or the union of where I would have marked oranges for the 3 jellyfishes that we have. So now that I've marked all of these orange, what I'm going to do is just do center marks on what's remaining here. And we shouldn't have more than, we've already eliminated 3 possibilities from all the oranges. We've eliminated the 6, the 5, the 6, and the 9. And we have other digits placed that see the oranges, so we shouldn't have too many possibilities in them. And I'm just going to go through each box one at a time, and I'm going to fill the candidates. And just remember, I'm never going to be placing a 5, 6, or 9 in any of these. So I'm just going to be looking at the box first. So this can be 3, 4, 7, or 8. This can be 1, 4, 7, or 8. This can be 1, 3, 7, or 8. And I'll go through the rows and columns and clean up after I do the boxes. So this is 1, 3, 4, and then 8. This one can be 2. It can't be 1, 3, or 4, or 5 or 6. So it's then 7 or 8. There's an 8 in the box as well. That's 2 or 7. This one can be 1, 2, 4, 7. These can be 2, 3, 4, 7, or 8. Oh, not 3. These can be 2, 3, 4, 7. Oh, not 7. 7's in the box. So that's just 2, 3, or 4. Is that right? Yeah, we have 7, 8 in the box, and a 1. And then these 2 can be 1, 2, 3, 4. There's a 7, 8, 9 in the box. Okay, so now we'll just go through each row and make sure that we've eliminated. So this has 8, 7, and 1, so this can't be 1. This can't be 7 or 8. And then columns, We have a 2 here, so these can't be 2. That actually places a 4, so let's just clean that up now. So that's our first naked single, and there's no way this would have been a naked single without finding all 3 of those jellyfishes. So that's clearly the intent of this puzzle, is you find that jellyfish, and then the puzzle becomes a lot easier. So we did the 2 here in this column, the 5 in this column, nothing in this column. This column has a 2, so that gives us another digit. So that 3 will clean up immediately. Box, column, row, and then that places this 2, which will clean up immediately. 2 here, nothing in the row. In the column, that places a 7, 7, which we will clean up immediately. And so that's that 7. And then that was the 2 we just found. So the 6 here, is there anything to eliminate? No, because that was part of the jellyfish. So at this point, the coloring is a bit less useful. All we have to do is remember that where we've center marked, those are the only possibilities. And we don't have to center mark everything. We just have to center mark the ones that were affected by those jellyfishes. And I wouldn't always recommend just immediately center marking anything affected by a jellyfish, but because we had the 3 overlapping ones, it's certainly a good strategy. And you can probably assume that the creator of the puzzle has caused at least 1 naked single as a result. So it's good to try to hunt for that. Okay, so, and I missed this, I think the stuff at the bottom here. I missed this 1 here. Did I miss anything else? 8, yes, this 8 here. Okay. Scanning is always the hardest part of any puzzle, probably. So now what I'm going to do is I'm just going to look for like my normal solving strategies, where I'm gonna start by looking for hidden singles and places where digits are limited to 2 places in a box, which is the same process where you just sort of look at how digits are looking into boxes and just marking when you see it's down to 2 or 1. This 2 looks up here and here, so this is a hidden 2, because again, we have this 2 and this 2. So this can't be 2, that makes a 1-4 pair. So this can't be 4, this can't be 1. We are at that corner marked, so we can just immediately place this 1. That doesn't have an immediate effect that I see. Okay. What else do we have? I was looking at 2s, I think. So 2s, look down here. So 2 is in one of these 2. 2s are looking here. That's 3 cells. I'm not going to mark that. Oh, but 2 is limited to these 2. So this 2 and this 2. So that then looks down here, and this looks across, and this looks down. So this has to be 2, and then this is 1. Just watching our pencil marks. So now we can do a 4 and a 1 here, but let's just make sure we're cleaning up as we go. So we place this 4. We have a 3-8 pair here, which I just saw. This 1 is cleaned up. And then does that chain react anywhere else? Not that I see. So we have this 1-4, we have this 1 and this 2. Okay, 2 is one of these 2. In this box we have a 2 here. So actually I could have just placed this 2 earlier. So that's where that goes. Are we done with 2s? Not quite. But this 2 actually sees over here. So this is the 2. This is no longer 2. That's a 7-8 pair. 8s are limited in boxes. What are these boxes? 4 and 7. 2 columns, 1 and 2. You can kind of think of it as an X-wing, but really what that means is that we have some sort of hidden pointing thing in this column here. So if we want to look at where 8s go in here, they don't go in these 2 cells. So 8's going to be in one of these 2. Okay, and that's really the only place 8s can go in this column. And just to show that's true, we have a 7-8 pair here, which eliminates this from being an 8. We have an 8 here, eliminates that from being an 8. We have a 3-8 here, eliminates that from being an 8. And so these are the only 2 places for 8 in this column. And since they're limited to the same box in box 1, the rest of the box can't be 8. Okay, so just to be clear what I did there. What was I looking at? I think I was only on 2s. Let's look at 3s. 3s look down into here. This is a hidden 3. I have a lot of 3s already. Okay, these 3s look up into here, and I've marked this as can't be 3. Ah, yeah, we have another 3 here. So these 3s look up, that 3 looks over. So that's not a 3, or sorry, that is a hidden 3, which sees this 7, 8, 7, 3, 8. This 7 is cleaning up here. And notice I've been kind of been able to do this without a lot of marking, just the corner marks. I've only gotten to 3s. Do I have all? I should be able to get. Yeah, this is a hidden 3 here. We have this 3 looking up here and this 3 looking over here. So that this was the only place for a 3. And I think 3s might be done. Yes, 3s are done, so we don't have to look at those anymore. How are 2s done yet? Or yes, 2s are done. 3s are done. Are 1s done? 1 is in one of these 2. Okay, so 1s are limited to this pattern here, which isn't resolved yet, and we have 1s everywhere else. Let's move on to 4s, see if we find anything. We have, yeah, these 2. Oh, sorry. This 4 looks here, this 4 looks here, this 4 looks up. Yeah, so this is a hidden 4. This 4 looks over here, so actually this is a 4-8 pair. Hidden 4-8, which means this is 6 and 9. Oops, this way, 6 and 9. And surprisingly, nothing sees that. Okay, and nothing sees this 4-8 either. Let's keep going. So I was looking at 4s. Where's 4 go in this box? 4's in one of these 2. And 4 is here. So that's a 4 and that's a 4. Did those 4s see anything interesting? No, we just have 4s limited like this now. Okay, how about 5s? So actually, I have a few boxes that are quite limited. Let's just do that. This needs to be 5 and 6. So that goes this way. That 5 sees here. So the 5 is one of these 2. Also in one of these 2. For this column, we need 5, 6, and 9, it looks like. This can't be 5. This can be any of those, so I guess that means this is also 5, 6, 9. But this can't be 5, so that leaves 6, 9, that's right. And then this would be 5, 6, 9 as well. This can't be 9, this can't be 6. Is this also 5, 6, 9? We have a lot of 5, 6, 9s left. This can't be 6. And this can't be 9. So I can, well, I might as well leave these 5s there. Okay, what am I looking for? Let's look at 9s. 9's in one of these 2. Ah, 8. 8 looks in here, and oh no, sorry, 8's already in the box. That's why. Where don't we have an 8? We need 8s here. 8's in one of these 3. 8's in one of these 3. Okay, maybe 8's not useful. Let's just keep center marking then, and we'll find something to do. What's going to resolve these 5, 6, 9s? Somewhere that sees a 5 and a 6, or a 5 and a 9. This is also 5, 6, 9, but it can't be 6. What are we missing here? We need a 5, 6, 7, and 9. So where does 7 go? 7's down here. So that's 5, 6, 7, 9. This can't be 7. This can't be 9 here. This can't be 5 or 6. Looks like we've got 5, 6, 7, 8 left of this column. This can't be 6. This column needs a 7 or a 9. Here we need 1, 5, 9. That's not 5. I'm probably missing something obvious. I apologize. This 6, 9 pair here makes this a 7. So that makes this an 8, which means this is 4 and 8. So this is 1. This is 4. This is 1. We have an 8 in the box now, so that's 5, that's 9. This is 5, 6, 7, 9. And this should be it. The puzzle's basically fallen apart at this point. So yeah, I hope you enjoyed learning about the swordfish and jellyfish. Maybe you learned something you didn't know about them, even if you did already know them. I'm just going to finish this puzzle. I have a hard time scanning while I'm talking, so maybe I shouldn't try. Okay, there's one left in this row. It's an 8. 2 in this row is 6 and 9. 2 in this row is 5 and 7. So it goes this way. I'm fully marked now. I shouldn't have any trouble. Ah, 6, 9 pair here, puts a 5. 6, 9, 5, 6, 9. Yeah, here we go. It's collapsing. And the 6's here. And there we go. So that is the Totes Jelly puzzle by Philip Newman. Sorry about the ending there, but as you can see, these puzzles are getting harder as the lessons get harder. So I will be taking a little bit longer to solve them in front of you. So hope you enjoyed that. Hope you enjoyed the lesson. Do let me know if you have any questions, or you just want to say, hey, I learned something from this video. Thank you. Like, I love hearing comments like that. Or if you have any additional information that you want to provide that maybe I didn't cover. But yeah, so please check out the puzzle pack that's provided by Philip Newman. They're all very high quality puzzles that involve swordfishes and jellyfishes. This was one of them from the pack he gave me. As you can see, it was a nice puzzle. You had to spot 3 jellyfishes all overlapping and then use that to solve the puzzle. So but you should expect the rest. In fact, I believe all of the swordfish puzzles are Star Wars themed, which is awesome. We have kind of the two sons of Tatooine, the binary sunset sort of image going on there, and a few other things. He's named them after little Star Wars stuff, so that's pretty cool as well. And so yeah, I also have puzzles that I've live solved, which involved a ton of different fishes. So feel free to check that out as well. And other than that, thank you for watching.